So the velocity or the perpendicular component in the y-axis gives the height and the velocity in the x-axis gives it the range, that is how long it is traveling. If any object is projected at a particular angle, then the maximum height of that particular particle can be obtained through this particular equation. Ax, that is acceleration in the x direction, is actually 0. Hey all, I am Hari Krishnan from the Department of Physics, Vidhyaashram PU College, the Temple of Excellence, and we were dealing with projectile motions. So we learned that a projectile motion is nothing but a projected object, that is an object being thrown or projected under the influence of an initial velocity at first, then traveling under the influence of gravity, eventually falling down onto the ground. We knew that the path followed or the trajectory of that particular particle will be parabolic in nature. And we also figured out what is the time of flight of that particular object. Now we have to find out some more quantities relating to that particular projectile motion. So let's get right on to it. So again, just to refresh your memories, from the first equation of motion, that is first equation of motion v is equal to u plus at, we derived a relation for time of flight of this particular object that is in motion. Imagine that I have thrown a rock and after some time it fell to the ground. So initially it had a velocity and after some time it traveled under the influence of gravity. That is, up to the maximum height point it was having the initial velocity I gave it. But after that particular height point, it is traveling under the influence of gravity alone. So we can say that in a particular way, this is the halfway point of the journey. And we know that since it was given an initial velocity, that is initial velocity vector v or u in this particular case, we can say that we can break down this particular vector into its x and y components or simply cos theta and sin theta components, and we can say that there is motion or there is a velocity in the x-axis and there is also a velocity exerted on the y-axis. So the velocity or the perpendicular component in the y-axis gives the height and the velocity in the x-axis gives it the range, that is how long it is traveling. The velocity in the y-axis gives how high it is traveling. So in order to measure the time of flight, we took that what was the time taken in order to reach a halfway point. That is, we knew that initially the initial velocity, the y component of the initial velocity was really high, and slowly as it reached the top, the perpendicular y component decreased and decreased and decreased. At the very top it became 0. That is, here the y component or simply vy was equal to 0. If I take that as my final point, then initial velocity was high and the final velocity, that is vy component of the final velocity, was 0. Make no mistake, there is an x directional velocity here. That is, there is a horizontal velocity which is making it to move forward. But the perpendicular y component now is 0 because gravity acting is cancelling out that particular y component. Now it is going to fall, that is, gravity is going to pull on it and make the object fall. So again, since the horizontal direction, that is the x-axis, is not changing throughout the journey, we are not going to consider that particular x-axis because again it is dealing with how long the object is traveling. We are only going to consider the y-axis, how long this particular object remained in the air for. And in this particular case, we are only going to consider half of the time taken, so that later down the road we can multiply it by 2 and we'll get the entire time taken. So here we are only considering the y component. So vy is equal to uy plus at. Here a was equal to minus g, minus indicating that the direction is downwards and t is indicating the time taken. Or simply we can see that vy component is actually 0 at this particular point. So it is our final velocity and our final velocity vy is 0, which means that this will be equal to uy plus minus gt. We can bring this to the left hand side and then we can say that gt is equal to uy. Again, from this particular figure, we know that if this is the angle theta, we know that uy is nothing but u sine theta. Always remember the y-axis, it will be sine theta because it will always be the opposite side of the angle we are taking, and the x-axis will always be the adjacent side, which means the x-axis will always be cos theta, the y-axis will always be sine theta. So we can say that gt will be equal to u sine theta, or simply t is equal to u sine theta divided by g. Now again, this was the time taken for this object to reach the halfway point. In order to complete the whole journey, we are going to multiply it by 2 because it takes twice as much as time. So we're going to multiply it by 2 and we will get the equation for time of flight, which is 2u sine theta divided by g. I'm just refreshing your memory. This is obtained from the first equation of motion. That is the important thing. From the first equation of motion, we obtain the relation for time of flight. Just like how we obtain the equation for time of flight from the first equation of motion, we are going to consider another equation of motion here in order to find out what is the maximum displacement in the y-axis, or simply what is the maximum height of an object, or simply a projectile that is projected with an initial velocity u. What will be the maximum height? How can we find out the maximum height using an equation? We are going to derive that particular equation here. So for that, I'm going to consider the equation of motion, that is v square is equal to u square plus 2as. Now, why did I consider this particular equation? Because I'm going to consider this displacement, that is, the displacement in the y-axis will be the maximum height. I'm going to find out what is this particular displacement here. So in this particular case, that particular displacement is equal to maximum height of this particular curve or parabola. So again, we don't need anything in the x-axis because we are only finding out the y components. What is the maximum displacement? So again, we are only going to consider the y components. V square y is equal to uy square plus 2 minus g into h. Here again, acceleration is provided by acceleration due to gravity, and s is the maximum displacement, or simply the maximum height of this particular curve, and that is denoted by capital letter H. That is denoted by capital letter H. Again, we know that at maximum height, the velocity component will be equal to 0. So we can see that 0 will be equal to uy square. We know that y, that is uy, will be equal to u sine theta, just like in the previous case. So u sine theta whole square minus 2gh. Now, while we square this, this will become u square sine square theta minus 2gh, or simply bringing this minus 2gh to the left hand side, we can write it as 2gh will be equal to u square sine square theta, or simply h, that is maximum height, is equal to u square sine square theta divided by 2g. This is the equation for maximum height obtained while a projectile is in motion. That is, if any object is projected at a particular angle, then the maximum height of that particular particle can be obtained through this particular equation. So we considered the equation of motion, that is v square is equal to u square plus 2as, and we took the y components of that particular equation. Since horizontal components can only contribute to how far the object is going, and here we only need the y component in order to understand the length, or simply the maximum height of this particular curve, we are only taking the y component, and Vy at maximum height is 0, so we took it as 0. Uy is already known, that is u sine theta, so u sine theta, and acceleration is provided by acceleration due to gravity. It is always acting downwards, that is why there is a negative sign. And here S is nothing but the maximum displacement, or simply the height of that particular curve, indicated by capital letter H. Rearranging this particular equation, we get the maximum height, or simply H max. Maximum height of this particular curve. Now, in order to be really precise, we have to know the angle and we have to know the initial velocity, acceleration due to gravity in that particular place. Then only we can obtain the maximum height of that particular curve. Now you must be thinking, okay, y is always being taken, there is nothing in the x direction. That is when horizontal range comes into play. That is, we are going to measure how long that particular object is going to travel. That is, when we threw a rock, we measured how long it was in the air for, how high it will travel, and now we are going to measure how far it is going to travel. So that is known as horizontal range, how long that particular object is going to travel. Now we are not going to consider anything in the y-axis. We are only going to consider the non-changing factor throughout, that is the velocity component in the x direction, which helps it to move in that particular direction. So I'm going to consider the equation of motion, that is S is equal to ut plus half at square. Now in this particular case, we only need the x components, that is Sx is equal to uxt plus half ax t square. Now what is Sx, or simply displacement in this particular x direction? That is what we are measuring, and that is horizontal range r. So I'm going to write this S as r, that is the horizontal range, how long that particular object is traveling. Now we have to know what is ux into t. Just like uy was u sine theta, ux will automatically be u cos theta into t, and plus half into what is ax. Ax is nothing but acceleration provided in the x direction. What is that? Is that gravity? Of course not. It is not gravity, because gravity is acting in this particular direction. That is, it is acting in the negative y direction. There is no acceleration being provided in the x direction. There is no acceleration provided in either way of the x-axis. So ax, that is acceleration in the x direction, is actually 0. Always remember, acceleration due to gravity is acting downwards, and acceleration here in the x-axis is 0 because acceleration due to gravity is downwards, that is in the y direction. We are only measuring how far it is traveling. We are not considering anything in the y-axis. Y-axis components are not being considered here. Only x-axis components are considered. That is how long it is being traveling. So ax will automatically be 0. This entire term will be 0. So half into 0. So we can write this down as r is equal to u cos theta t. Now t here is the time taken for this object to reach this particular position, which means that particular time taken is actually time of flight. So that particular t is actually, t is equal to 2u sine theta divided by g. That is, time taken to reach there is nothing but time of flight, how long it traveled until it reached its very end in the ground. So time of flight is 2u sine theta by g. When we substitute that, we will get r is equal to u cos theta into 2u sine theta divided by g. Or simply rearranging this particular equation, you can write it as u 2 sine theta cos theta divided by g. And if you have paid attention to your trigonometry classes, you will know that 2 sine theta cos theta is actually equal to sine 2 theta. That is, it is a trigonometric identity that dictates 2 sine theta cos theta is always equal to sine 2 theta. So we can rewrite this particular equation again, and we can write horizontal range R is equal to u sine 2 theta divided by g. So this is the equation in order to find how long that particular object has traveled, or the horizontal range. So it is R is equal to u sine 2 theta divided by g. U square sine 2 theta divided by g, because it is u cos theta into 2u sine theta. So there is one u here, one u here. So u square 2 sine theta cos theta, 2 sine theta cos theta will become sine 2 theta. Then we can write it as R is equal to u square sine 2 theta divided by g. So the two u's multiply together and they become u square. Really sorry for missing that. Please don't miss that in the examination. These two u's multiply together and it is u square. And 2 sine theta cos theta is sine 2 theta. So regarding projectile motions, there are 3 important derivations and 3 important equations you should know. So the first equation is 2u sine theta divided by g, that is giving the time of flight obtained from the equation of motion, that is v is equal to u plus at. Obtained from this equation of motion, we have time of flight. And now the second one is maximum height, that is h is equal to u square sine square theta divided by g. Now this is obtained from the equation v square is equal to u square plus 2as. Now again we have the last equation, that is horizontal range, and r is equal to u square sine 2 theta divided by g, obtained from the equation s is equal to ut plus half at square. So the 3 equations of motion has now given a rise to the 3 equations of projectile motion: time of flight, maximum height and horizontal range. So these 3 equations are very important. You should know it. Even if you are waken up from sleep, what is time of flight's equation? You should say all these 3 equations. Now we also have some special cases where we get the maximum output from these particular quantities. What is the minimum time required, or what is the maximum height that can be achieved, or what is the maximum range that can be achieved? At what angle should we project the projectile so that we get maximum results? That is special cases. So in order to get the maximum time factor here, the maximum time factor here can only be obtained if sine theta is equal to 1. And sine theta is only equal to 1 when theta is equal to 90 degrees. So when theta is equal to 90 degrees, we will get time of flight t is equal to 2u divided by g. That is the first special case. And similarly like this, we can obtain equations for maximum height and horizontal range. For maximum height, the equation is h is equal to u square sine square theta divided by g. Again, theta is equal to 90 degrees, which means that h is equal to u square by g. So if we are throwing any object upwards at a particular angle, that is 90 degrees, it will have the maximum height and maximum time of flight, depending on only the initial velocity we are giving and acceleration due to gravity of that particular place. Depending on only the initial velocity and acceleration due to gravity in that particular planet or place. That is, if I'm only giving 2 meters per second, it will only go in the air for some time and it will come down. But if I'm throwing it at a particular angle, that particular time of flight will decrease. Don't measure from any height your reference frame is from. So again, If the angle is theta for time of flight and maximum height, we will get the maximum output for these quantities. It will be depending only on the initial velocity, acceleration due to gravity of that particular place. And in the case of horizontal range, we can say that theta is actually equal to 45 degrees. So, in order to get maximum distance covered, we have to throw some object at an angle of 45 degrees. Why? Because here it is 2 theta, which means that u square sine 2 into 45 divided by g, so that we get sine 90 again, the maximum value, so that we get it as u square by g. So maximum range will only depend on initial velocity and acceleration due to gravity if we are throwing it at an angle of 45 degrees with the horizontal. That is why when javelin throwers are throwing the javelin, they try to throw it at 45-degree angle, because then it will travel a long distance. If you want to throw anything really far away, it is always better to throw it at a 45-degree angle. If you want it to reach a long way, if you just want to make it fall to your head, you can just simply drop it high up so that it falls on your head. So that was all regarding projectile motion, that is maximum height, horizontal range and time of flight, and the special cases we discussed where the angle actually matters. So I hope you have understood everything about projectile motion. I'll see you all again very soon with an interesting topic from this particular chapter. Thank you.